degree of relationships are there. One is binary relationship, another one is ternary relationship. Now binary relationship means the degree is 2, and ternary relationship means the relationship degree of relationship is 3. So see the example where the degree of a relationship is 2. For example, employee. Employee works for department. So works for is a binary relationship. And for ternary, supplier supplies part to the projects. So here supply is a ternary relationship where S supplier supplies part P to the project J. Okay, so that is the degree of relationship, that what are the number of entities participate in a relationship. Here see, only 2 entity types, department and employee, are participating in a relationship works for. That's why it is degree 2 or binary relationship. And here 3 types of entities, supplier, part and project, are participating in the relationship, so it is of degree 3 or ternary relationship. Now next one is the mapping cardinalities. Now it is very much important, listen it carefully. uh, the one thing I can say you, the notes that I have shared with you, already I have taken it from the different books, sometimes from Korth or some parts from Navate, because all the parts are not in a single book. The entity relationship model is uh, well described in the book that is Navate, and again normalization part is from Navate. But transaction part is from Court. So from different books I have jotted down it in my notes. So I think it will be helpful for you if you follow my notes for definitions and uh, other examples. Here it is summarized actually. So mapping cardinality or ratio for binary relationship. Now, mainly the cardinality ratio or mapping cardinality is defined for binary relationship. For ternary relationship, generally it is not defined. That's why it is mentioned here. So the definition is number of entities to which another entity can be associated by a relationship set. Number of entities to which another entity can be associated via relationship set. For example, I am a teacher, so I am associated with 60 number of students of electrical 1. So the cardinality between in this scenario between the teacher and student, the cardinality ratio is, from my side it is 1, and from other side it is 60, 1 is to 60. Okay, so in this way, in ratio format it is given. For example, here employee works for department, so here n number of employees is working for one department. So here the ratio of uh, employee is to department is n is to 1. That is the cardinality ratio. So so here you can see that. So on the mapping cardinality must be of different types. So first one is one to many. So that example I have given, that in works for relationship between department and employee, department is to employee is of cardinality ratio 1 is to n, that I have shown you. Department is to employee is the ratio 1 is to n. One department has n number of employees. The n is the generalized form. It may be 5, it may be 10, it may be 100. And if you so it is one to many, so that is one to many. Now next one is meaning that each department can be related with any number of, that means zero or more number of uh, employees. Okay. uh, but one employee is related to only one department. Okay, one employee belongs to only one department. One department has n number of employees, but one employee is uh, associated with only one department. Now the next category is the opposite one is, it is one to many, the opposite one is many to one. It is one to many, the opposite one is many to one. Many to one means there the vice versa relationship, the opposite one, that means the employee is to department is n is to 1, that is many to 1. Many employees are working for a single department, that is many to 1. Next one is 1 to 1. 1 to 1 example is, for example, in a single department only one HOD is there, so one HOD manages one department. Okay, so that is written here that when an employee manages a department, then uh, the ratio between the manager and department, or HOD and department, is 1 is to 1. HOD manages department, the relationship is manages, so the cardinality ratio between HOD and department is 1 is to 1. And many to 1, many to 1, that means employee works on projects. That is one employee works for different projects, and also one project is uh, having a number of employees. So here the cardinality ratio is m is to n. An employee can work for several projects, and a project can have several employees. So for the works on relationship, the cardinality ratio is m is to n. The cardinality ratio for works on relationship is many to many, m is to n. Actually you can write it n is to n, but the two common terms are there, then n is to n is the n will be common, that's why it is written as m is to n. Also you can say that between teacher and students, a teacher is teaching many students, and a teacher and a student is taught by many teachers. You are taught by a number of teachers, so you can also give that example that teacher is to teaches student. The teacher's relationship, the cardinality ratio may be m is to n. In the scenario where one teacher is teaching a number of students and one student is taught by a number of teachers. So this is the cardinality ratio. 4 types of cardinality ratio is here. Now I'm sharing the PPT. Then it will be more clear to you. Up to this we have done last day, yesterday. So today we are starting from here. Um See here, um, he works on job at a particular branch. Employee works on job at branch. Now see, when the ternary relationship is shown, all the attributes of the entities are shown also. Okay, and this is the mapping coordinality constraints that you have just covered up. That is, it is most useful in describing binary relationship. And another thing is that for binary relationship, it is easy to convert it into a relation tables, but for ternary relationship, it is quite complex to convert them into relational tables. Now the four types of coordinate ratios that I have told you. Now see here, it is shown in terms of mapping, as it is called mapping coordinality. So you can say that it is also expressed in this way diagrammatically, that 1:1. That means one, if it is entity A and it is entity B, so it is entity type, so a set of entities are there. Here also a set of entities are there, and here you can see that 1:1 means the relationship or mapping is 1:1. You can see it 1:1. And when we are showing that many, one to many, then one element is mapped to a number of elements. So 1:1 means one HOD is managing one department. For each department, one HOD is there. If it is the department type and if it is the HOD type, so one HOD is allocated for each department. Now, if it is that I have told that one to many, it may be um, employee or you may give it that student is to teacher. Okay, uh, maybe it is the teacher set A and it is the student set. So you can say that a teacher is maybe it is the private tuition, example of private tuition. So a single teacher is teaching two students. Here also a single teacher is teaching two students, and here one teacher is also is teaching only one student. So in one is to many relationship, it is not that all the relationships should be one is to many. It may be one is to one also, but in one is to one, no chances of one is to many. You can take the example of private tuition. There teacher is associated with a few number of students. So this A1 teacher is associated with students B1 and B2. A2 is associated with B3 and B4, and A3 is only associated with B5. Many to one. It is the just opposite one of the one to many. Okay, yeah, there it may be the students set and it is the teacher set, private tutor set, and many to many, that is employee works for project. That maybe you can say that one, if it is the employee set and it is the project set, then A1 employee is working for the project B1 and B2, and the B1 project has the employees A1 and A2. Now A2 is working for B1 also, and A3 is working for B3. Similarly, A4 is also working for B3. So it is many to many cardinality ratio or mapping cardinality constraints. As it can be represented using mapping, you can say that diagrammatically we can represent it using mapping. So you can say that it is also mapping cardinality or cardinality ratios. It is that already I have done. I have told you that Johnson is associated with a number of accounts. Yesterday we have seen it that uh, in the depositor table it is given that Johnson is associated with A101 and also A201. Smith is associated with A215. Hayes is only A102. Now here Jones is associated with A217 and Lindsay is associated with A222. So you can say it is one to many. Okay, one is associated with many. Many to one you cannot say it. Okay, one to many. Yes, many to one. The opposite side is you can say that account is to customer is many to one and customer is to account is one to many. Okay. uh, okay, that is saying that um, when one-to-one relationship, then we express cardinality constraints by drawing either a directed line signifying one or undirected line signifying many between the relationship set and entity set. So see, it is as so to signifying one, we are giving a arrow directed line, and to represent many side we don't give an arrow sign, only undirected line. So here both sides direction is given. That means a customer has only one loan account, and loan account only belongs to a loan account belongs to only one customer. Okay. um, then see the one to many, so it is one is to one, it is one is to one, both side is one. That's why in the both side one the arrow is given. Okay. Now, as it is one is to many, the same thing can be represented in another scenario. For example, in some bank or branch, it is that the loan account is belonging to only one customer only, or only our customer is only one loan account. Then the relationship between one is to one. So that's why the arrow is given in both direction. But if it is one is to many, one to many, that means one customer has number of loan accounts, or see one to many relationship. A loan is associated with with at most one customer, but a customer is associated with several number of loans. So one it is one is to many. Now one customer has several number of loans, but a loan is associated with only one customer. Now, when we are saying it many, many means 0 to n. That means when we are seeing the mapping, we can see that 1 is to many. That means some loans are not associated with any customer also. If you can see the mappings in 1 is to many, here, see, If it is many to many, that means many to many means 0 to n. So here see, one element is not associated with any other. Okay, so it may be possible that when we are saying that one is too many, it may that one customer may not have any loan. So 0 to n, many means. And here also many to one. That means in some scenario, if it happens that n number of customers may borrow a loan, but n number of customers is borrowing a single loan. That means a loan is having a number of customers. So it is see, as the customer side is many side, that's why it is no direction is given here. Only in the loan side arrow is given, and many to many, in this case no arrow is given. Okay, many to many means 0 to n, and here also 0 to n. Many means 0 to n. Okay, so see, a customer is associated with several, possibly 0 loans via borrower, and a loan is oppositely, a loan is associated with several customers. Several means possibly 0 also via the borrower. So many is to many. Here the directions are here no directions are given. So now tell me, up to this any problem is there? All of you have understood, or this degree of relationship and cardinality ratio, all of you have understood clearly? I have shown you PDF as well as the PPTs, that where the how to represent the different cardinality ratios through diagram. Also, I have shown that. So I think it will be clear to you. Okay. So okay. Then one thing I have left, that is unary relationship. So I will coming to that part. The thing I have shown in the PPT, that is given here. Employee department, employee works for department 1 is to n, employee works on project m is to n. These things are shown here. Okay. So before going to unary relationship, I will first show you the thing that is participation constraints. So participation of an entity set E participation of an entity set E in a relationship set R. Say the entity set is represented by capital E, and relationship set by capital R is of two types: total and partial. Now total means if every entity in the entity set E participate in at least one relationship instance in R. That means participation of employee in works for is total. I'm explaining. Just let me read out the definition, then I will explain. If only some of the entities in an entity set E participate in a relationship in R, then participation of entity is called partial. Okay. Now, for example, mm, Let me the example is given here that okay, let me give you this example, that is customer borrows loan. Now in a bank, the a number of customers are there, who have saving accounts in that bank. Now among them, some of the customers, this is the real scenario, among those customers, some of the customers are taking loan from the bank. So if we are making a relationship between the customer entity set and the loan entity set, then you can see that all the entities of the customer entity set is not participating in the borrows relationship, because all of them are not borrowing a loan from the bank. So all of the customers are not participating in the borrows relationship. So that's why the participation of customer in the borrows relationship is partial. But when there is a loan, a number of loans are there, so it is expected that all types of obviously a different number of loan accounts are there. So obviously when the loan accounts are created, that means against each loan account, obviously some customer is there. That means all of the loan accounts are participating in the borrows relationship. Okay, without a customer, no loan account should be there, because the customer is taking the loan. So that means all the loans are participating in the borrows relationship. Okay, all the loans are belonging to uh, or borrowed by some customer. So that's why all the loans are participating in the borrows relationship. That's why the participation of loan in the borrows relationship is total. Now total relationship, the total participation is shown by double lines, and single and partial participation is shown by a single line. Okay. And if you are, and here it is told that the participation of employee in works for relationship is total, because obviously all the employees are working for some project or for some department. The works for relationship actually given in case of here, the here employee works for department. Obviously all the employees are works for some department, no employees are without a department. That means that's why the participation of the employee in a works for relationship is uh, total. Okay, it is not shown here because till now you have not learned that, that's why it is not shown here. So that is the definition of a total and partial relationship. So this participation constraints total participation and partial participation is cleared. Total participation and partial participation is cleared. Okay, because it is easily understood by the customer and loan, the relationship between customer and loan. Okay, it is very easily described. Okay, now next one we are coming, that is recursive relationship. Now recursive relationship is that you can first let me explain the diagram, that for example, um, some company there are supervisor and supervisee, both type of employees are there, and you can see that in the if the relationship between supervisor and supervisee is supervision, that is supervisor supervises supervisee, or you can say that HOD manages faculties. Okay, HOD manages faculties. I'm giving you a single simple example. HOD manages faculties. So HOD is here supervisor and faculties are here supervisee. And HOD supervises or manages the faculties or supervises. Now, in this case, the relationship between the two entities. Now here you can say that the two entities are belonging to the same entity type because both are employees. Supervisors is also employee of a company. Supervisor is also the employee of a company. Similarly, HOD is the employee of that company. Similarly, the other faculties are also employee of the college, company or college. Okay. So in some cases, the same entity type, that is employee, same entity type, participates in a participates more than once in a relationship. Okay. In some cases, the same entity type participates in a relationship more than once in a relationship in a relationship more than once in different roles. Same entity type participates in a relationship more than once in different roles, once in role of supervisor and secondly in role of supervisee. So here the role name in different roles, here the role name is required for distinguishing the meaning of each participation. So such relationship is called recursive relationship. In C language, you have learned about recursive function. That means when same function calls itself in its body, then that function is called recursive function. So almost that type of concept is used here. That means same entity type is participating in a relationship in more than once. More than once, it is participating in the relationship in two different roles, once in role of supervisor and next time in the role of supervisee. So this type of relationship is called recursive relationship. Supervision relationship relates supervisor and supervisee. Both are members of same entity type employee. So employee entity participates twice in supervision in two different roles. So that thing is so that is explained here in the PPT. That is unary relationship. You can say here, see here. So when recursive relationship is actually represented as a unary relationship where the degree is 1. Why degree is 1? Because in this relationship the number of entity types participating is only 1, that is employee. That's why it is also called unary relationship. So the recursive relationship and unary relationship, here see it is given that employee, manager and worker, that I have told, supervisor and supervisee. Manager is the supervisor, worker is the supervisee. Okay, so worker, actually it should not be box for, it should be supervision or supervises or supervisee, this type of relationship. Okay. Here actually it is shown that employee works for employee. That's why it is shown in this way. Employee, that is worker, is working for the particular employee, that is manager. So so that is the thing. So tell me, up to this any problem is there, or all of you have understood up to recursive relationship and unary relationship? It is very much important. Up to this, whatever I discuss today, all of the things are very much important from this chapter. Okay, so okay, repeat the unary one. Okay, unary relationship. You can see that here. Unary means the degree of the relationship is 1. Binary means degree of relationship is 2. That you can see here. The two number of entities are participating in a two types of entities are participating in a relationship. So here unary means in a relationship the participating entity type is only 1. So here in the recursive relationship, you can say that the employee is only participating in the relationship works for once in role of a worker and second time in role of manager. So you can say that worker works for manager. But this worker and manager both are of the entity type employee. Worker is also a employee, manager is also a employee. So actually only one single entity type is participating in this relationship. That's why the degree of this relationship is 1, degree 1. That's why it is called unary relationship. Okay. Now it is clear. Anish.
Yes, ma'am, clear.
Okay. Then so today I will conclude here. Uh, Up to this, today I will conclude my class here. Okay. From next day we will go into the other parts. Okay. So okay, and all of you must do the assignments that I have given. Okay, because on the Monday, and another thing I am telling you, um, on Monday, I am taking the joint lab because the group A and group B both are free. So jointly, I am taking the lab for group A and group B. So who have missed the lab? So that is not a very difficult one. Tell any one of your friend to. Already, I have shared the two online compilers link in your group so that you can do it. And if you have missed it, so you can take help from any of your friend so that on Monday you can show me, you can submit me the um, assignments. Okay. Momita, have you done the lab last day? No, ma'am. I think this time it will be more serious. Okay. So be serious and do the classes and labs seriously. Don't be so much casual. You are now in 4th year. Okay. In the first year, I have seen you, but I hope now this time you will be more serious. So do it carefully if you have missed it, because on Friday already I have told that actually I have taken the lab on the Monday jointly, and also on Friday I have some meeting also. That's why I cannot take. So who have missed the lab in Monday, please contact to your friends who have done the lab, and it is very much easy to do the um, labs in online compiler. So I think you can learn it very easily from your friends, and on the next day again I will show. So okay, I'm now ending here. Thank you. And on the Monday, possibly possibly not, all of you join in the lab. Okay, that will be the common lab for group A and group B both.
Okay, ma'am. Thank you.